So, good morning, good afternoon, and in my case, good evening. And welcome to the VPG Force Sensors webinar. Today, we'll be focusing on precision measurement for the construction equipment and the construction industry. Obviously, still waiting for a few people to join the call. So. Before we start, we would like to just run through a few housekeeping items. So today, as I said, the webinar is focusing on our solutions for the construction industry, and we expect the webinar to last around 30 minutes to 45 minutes. What we would ask is if you do have any questions or that would require answering, please use the Q&A function rather than the chat function. We can answer those as we move along, but most likely we'll come to those at the end of the presentation. If something needs answering and we spot it, then obviously we'll action that as soon as we see it. What I would ask is shortly you'll see a brief questionnaire. There's just a few questions, not only to help us during this presentation, but to help us in future webinars that we will host with our customers. And yeah, you'll see that shortly. And also at the end, we will issue a brief survey with some really quite basic questions that we would hope to receive some feedback on. And obviously that will help us in the future moving forwards. So for now, we'll just wait for a few moments. If you see the questionnaire, please do interact with that, and we can move on through the presentation shortly. Okay, so thanks very much for the questionnaire results, and yeah, we can move on. So just by way of some introductions, we have two hosts today. Myself, my name is Darren Preston. I'm the VPG Force Sensors OEM account manager based in the EMEA region, based in the UK, looking after our customers in Northern Europe. I look after predominantly all of our markets, but where I am, it's heavily focused on construction, agricultural industry. Yeah, I've been with VPG for around 2 years now, with my heavy focus for previous working life in sensors and the EMEC industry for the last too many years to remember. So yeah, I'll hand you over to my co-host, Richard.
Thanks, Darren. Hi, everyone. My name is Richard Rogers, and I am one of the OEM account managers supporting the construction and agriculture markets here in the U.S. I've been in the load cell business, if you will, for going on 34, 35 years. Recently back with VPG, and really excited to work within the segment that I've been given, is construction and agriculture. Also joining us today is Tal Rahav. Tal is our Director of R&D, and he is based in our state-of-the-art design facility located in Modi'in, Israel. So Tal will jump in and answer any questions we might have as we move forward.
Good evening, everyone. Nice
There
to
he
meet
is.
you.
Hi, Tal.
All right, as for today's agenda, we're going to learn a bit about VPG's background. We're going to we'll see how VPG supports construction in the machinery market. We will review some force sensing applications, and we'll close with a question and answer session. So let's start by talking about who is VPG Force Sensors. Well, we are a leading design manufacturer of precision force measurement and sensing technologies. Simply stated, we develop the world's most advanced force measurement sensors used in applications worldwide, whether it's construction, agriculture, medical devices, general weighing, food processing, aerospace related, or many others. We have more than 60 years of engineering experience and expertise to draw from to optimize and enhance our customers' product solutions. Bottom line, if there's a force measurement application in the market, odds are a VPG branded solution will be involved.
So thanks, Richard. So yeah, so just moving on to who we are and where we've come from, really. So a quick snapshot of the history of how we've become VPG Force Sensors. The company Vishay was founded by Dr. Felix Sanderman, and I would very much recommend that you look through to the history outside of this call for the history of Dr. Felix Sanderman. He was the founding father of our company. He developed and designed the first ever foil resistor, and slowly moved on into the area of strain-gage technology. And with strain-gage technology, we were obviously selling our strain gauges to many different applications, obviously including load cells. And obviously to develop the company further, we actually acquired various load cell manufacturers, including Tedea-Huntleigh, Celtron, BLH Nobel, Sensortronics, and latterly Revere Transducers. We then formed our Vishay load cell division, which was established in 2018, where VPG Force Sensors was born. We're now VPG is a listed company, public traded company, and backed up by the wider Vishay group, with our founder, Dr. Felix Sanderman, being one of the founding fathers of the Fortune 500. So we're a very well-backed company, investing in new technologies and, more importantly, people. And we continue to progress in our technology development. So in terms of our worldwide presence, obviously, as Richard alluded to, our head of R&D is with us today, Tal Rahav. We are headquartered in Modi'in in Israel. This is where all of our R&D, sales, marketing functions are based, and that's where all of our research and development is taking place. Our main manufacturing facilities, we have Tianjin in China and Chennai in India, various sales offices throughout that region. From my particular perspective in Europe, I'm based in the UK office in Basingstoke, but I look after the northern half of Europe. We also have very small manufacturing facilities in Chartres in France, and also in our Basingstoke facility. We'll touch on some of the additional options that we have outside of force sensing and load cells later on with Richard, but we are able to produce bonded forked strain gauge solutions in both of those facilities. We also have a headquarters of our European office in Heilbronn in Germany, which is halfway between Stuttgart and Frankfurt. And I'll pass over to Richard to explain the US operation.
Sure. Our US sales office is located in Ontario, California, which is where our excellent customer support specialist team is based. This group provides sales fulfillment and customer support for North, Central, and South America. We have 8 dedicated segment managers located throughout the U.S. that work directly with our OEM customers and our distribution partners. Combined with our worldwide technical support staff, this team is a highly dependable and we're an engaging group of individuals with a common goal to satisfy our customers.
Thanks, Richard. And also, just based on our European team, we're a similar kind of size, with our head of customer service based in the UK, who works very closely with myself and also looks after the France and Germany office. We have a team of around 15 people in customer service and around 8 people in equivalent positions to myself, looking after the various different regions. And next slide, please. So in terms of certifications, which is particularly important to the construction industry and all industries we serve, in particular medical and aerospace, all our production facilities are approved to ISO 9000, and we're subject to regular QA reviews by the relevant inspection authorities for all of the approvals you can see at the bottom of the slide there. But not only that, we also welcome all of our customers to perform audits at all of our production facilities when necessary. We obviously have our standard load cells, but we also have our standard load cells that have metrology and hazardous area approvals. The products are designed to meet critical applications and market standards and directives, like those of medical devices, construction safety, and other internal approvals. Particularly with regards to construction safety, we'll touch on some of the safety standards that are being implemented. Not only are they running currently, but there are new regulations within Europe specifically, and also in the US, and we'll touch on those when we come to more of the application slides. So in terms of the VPG Force Sensor strengths, we are a market-leading company in our focused market segments. We learn with our customers and provide the most effective solution to meet the customer's requirements. This is backed up by our significant R&D capabilities based in Modi'in in Israel, headed up by our colleague Tara Hav, who is on the call today, with a creative, flexible, problem-solving approach. We offer high-quality manufacturing facilities with let I say, movable capacity and competitive cost structure. We're part of the VPG group, which is the part of the wider Vishay group. Well, so we are a very well capitalized company, being part of a Fortune 500 company. And the organizational culture is very much based on a highly experienced and committed team. We are very much cross borders, as you'll see today. The European team often interacts with the US team, and vice versa with our colleagues in our manufacturing facilities in China and India. In terms of our assets, we have a broad portfolio of standard products, but our main focus with all of our leading OEMs is to provide the right solution to the right application. The majority of all of our high-running products are custom, and we'll run into some of the customization options that we offer later on in the presentation. We're a well-known high-end brand of a well-known high-end product range, with a long history of innovation, be that Tedea-Huntleigh, be that Celtron, Revere, etc. And long-term relationships with the major OEM market leaders, which you'll see in the presentation later on. We interact very well with these customers, and we're very trusted partner in many of these customers. Richard, any comments?
Yeah, we'll move forward here on the next slide. Following up on that last bullet point with the relationships, when it comes to addressing the unique challenges of the construction industry, next slide, please. It's because of those relationships that we've built over time with these OEM customers, that we are in tune with their requirements and can work with them to provide a force monitoring solution that will lead to a safer operating experience for their customers. The machinery OEMs are well aware of the risks and costs associated with unsafe machinery operation, and they do everything they can to limit it. They understand that operating a machine in an unsafe manner can lead to site damage, project shutdowns, and in worst case, injury to the operator or those that are nearby. VPG designs and manufactures sensors to ensure our customers' equipment meets the highest construction safety standards, similar to what Darren has just touched on, such as ANSI B56 for lift trucks, ANSI A92 for mobile elevating work platforms, and there's a new release to EN 474 related to earth moving machinery that's on its way, and Darren will touch on that in a bit. There's also EN 1459, which relates to rough terrain vehicles, mostly towards rough terrain lift trucks. And we'll talk about some of that a little bit later. When it comes to new applications, the design engineers at VPG work closely with our customers to examine and comprehend the entire scope to better understand all the forces a load-bearing system will encounter. Only then can the VPG team provide a sensor solution that is designed to meet the anticipated structural, environmental, and safety requirements, which will provide the reliable and safe performance our customers expect. Next slide. All right, trusted partner, keep touching on this. VPG is highly regarded by its construction OEM partners to collaborate and provide sensor solutions that provide the safety and reliability they require. When we talk about reinforced safety, sensors can now include multiple unique outputs to support redundant safety mechanisms. VPG's electronic design engineers are transforming the way our customers use force sensing technology in their applications. With our newest digital circuitry using CAM, this can be embedded within the sensor to provide up to 4 unique measurement types, like force, angle, temperature, and even vibration. That's multi-layer protection built directly into the sensor. Our sensors are designed and manufactured using state-of-the-art technology that guarantee the precision and reliability our customers expect. Drawing on VPG's historical experience and expertise in providing innovative sensing technologies allows us to shift the boundaries of where force measurement can be employed. We'll explore a couple examples of this innovation in the next few slides. Next. All right, so now let's talk about a few of the machinery applications where VPG sensing technology is applied. You see here a list or images of various applications, telescopic handler, various types of lifts, the boom and scissor, lift trucks. We have cranes, loaders, front-end loaders, and stackers. We touch on pretty much all of these applications. Next slide, please. Now let's get into the individual applications. One critical application is with the highly versatile telescopic handlers. You see these all over the construction environment. Not just in construction, by the way. This same implement or device is used in forestry, it's used in agriculture, it's used all over the place. They changed that front-end implement to suit the needs, but the core application is the same. VPG provides the Model 182 extensometer, which is applied to one of the rear axles and is intended to measure the change in the axle as weight is distributed to the front of the vehicle. The purpose here is to notify the operator that the vehicle is becoming unstable when losing traction or is lifting and may tip over. The standard indicates the original bare minimum application required that an indicator like that 7-segment LMI display be included in the cab for quick indication of unsafe operation. Most applications now have this information embedded in the onboard HMI screen, where the information may trigger onboard responses to unsafe conditions. For stability, they may apply 2 extensometers, one on each rear axle, which gives them roll stability for uneven ground. This is more application specific by the customer. Next slide. Oh, wait a minute. Let's back up. I'm sorry. Let's back up for a second. I talked about this platform for telescopic handlers. The orientation of the wheels and the axle and so forth, it's very similar to an application that Darren's been working with. And I don't know, Darren, if you wanted to talk about that loader.
Yeah, thanks, Richard. Yeah. So obviously, it's as Richard says, it's a worldwide application used across many industries, not just within the construction industry. And as we referred to earlier in the presentation, there's a new regulation currently, I guess, specific to Europe, which is the EN 474-3, specific to loaders. So although these machines are used as telescopic handlers as well as loaders, they have to perform to this new regulation. For the customer we have in Europe currently, we're using the same solution with our 182 extensometer. And with the help of TAL and R&D, we were looking at how we can meet this new approval with a customized version of the 182. Now the challenges the OEM in Europe currently has is that with this new regulation, there's some challenges with regards to where the sensors need to be positioned on the axles, and where they have to position them to get the correct readout is concerning them with regards to space. So we're now actually looking at some slightly different solutions. There's some more discussions to have, but it may transpire that not only will they need a 182 extensometer on one of the axles, they may need some of our load pin solutions, which we'll come to in some of the next slides in the actual boom of the lifting part of the machinery. So yeah, as we say, we're ever evolving with the market requirements, and yeah, we're working with our customers to try and find a resolution. So yeah, thanks, Richard.
Yeah, just to elaborate a little bit more on this particular application, you see on the image here that we provided, there are some levelers or some support arms that are on the front of this device. They have them sometimes in the front, they sometimes have them on both rear and back. And they will mount the extensiometer on those arms as well, or they may apply load pins in the unions there. And when that happens, that tends to deactivate the sensors that are used on the axles. So it becomes a real complicated solution, and we're involved in pretty much all aspects of it. So next slide. All right, so now we're going to start talking about some scissor lifts. This gets into the mobile elevated working platform world, and to meet the platform weighing requirement, VPG offers standard and customized load pins for these machines. For scissor lifts, typically you can see where the blue and the green circles are there. The sensors are mounted, the sensor mounting location is typically applied in the uppermost hinge point where the extensions meet the platform base. Depending on the machine size and mechanics, you may be able to get away with only 2 pins, but typically 4 pins are required, 1 in each corner. In some instances, on the larger platforms, in order to keep the platform centered, there is a connection directly to the platform where a 5th pin is applied at the base of an actuator. This is common on bigger platforms where the hinges move on both ends. What is shown here on this image is the right side is fixed pins, and on the left side, the pins are moving. For larger platforms, typically the center is fixed and both sides move. The sensor output is available in all different types of configurations, including adding tilt, which is a requirement of ANSI A92 or EN 280. The 2 key requirements, and this applies for mobile elevated working platform. The 2 key requirements for these applications is 1, the lift must have sensors to prevent the machine from operating when safe load limits are exceeded. So they get to determine what that safe load limit is. And then 2, a tilt sensor must be included that prevents movement of the chassis or the work platform when a certain level of slope is exceeded. So they don't want the thing tipping over. So those are the 2 requirements where we've come into play for these MEWPs. Next slide. We just briefly mentioned booms. So this is a straight boom. VPG is partnered with the primary OEMs for this type of lift platform. Each OEM has a unique solution for weighing the basket to meet the ANSI or the EN safety regulations. In the straight boom, where they're only weighing the basket, most instances, we have 1 shear beam sensor with redundant output that's mounted at the union of the boom to the basket. They have different architecture to support the basket to the boom, but it's all the basic same principle. The majority that we're providing all include CAN bus for communication. There are a few other applications or variations where they've used 3 or 4 shear beam load cells to support the weight of the basket. But primarily we're back to just using one now that we, VPG designed and engineered a single shear beam load cell that was specific to this application. To protect against environment, the load cells can be EDOT coated, which Darren's going to touch on a little bit later, with bonded covers, or you can have stainless steel with welded covers. VPG can configure to meet the customer's application requirements, whatever they need. That includes connectors and so forth. Another thing to touch on here is all of these products are geared to operate off the 12-volt automotive power, because that's what's typical in this industry. Darren, I think you have something here to talk about. Next slide.
Yeah, so just expanding on the mobile elevating lifting applications. So a lot of our customers, they have different ways of meeting the regulations, but different ways of packaging the products and different ways of achieving the sensing solutions they needed. This is a customer here based in Europe, where instead of a shear beam, we're using a high capacity single point load cell, which is basically used to measure the overload in the basket. Not only are we producing a custom load cell in terms of the electronics, as Richard's already alluded to, with a CAN open, an additional tilt sensor integrated, but we're also able to manufacture the solution to suit various different platforms, different weight categories, etc. A lot of these vehicles are very similar but very different. So they're very different in size, different in reach. But nowadays, we're also looking at not just diesel powered, we're talking hybrid powered, which are a lot heavier. So the load cells need to interact with the different platforms that they're in. So at the moment, we're looking at 3 different designs within this customer. And again, we're offering the EDOT coating, which I'll touch on later. Custom cable lengths sealed into the load cell itself with a sealed connector. So yeah, some just an expansion and a different way of doing it for different customers, to add to what Richard's already mentioned, really. Next slide.
All right, so now we're moving into the big guys here. This is the big articulating boom lifts with much longer reach. There are a few main load sensing applications. The same issues apply here with they need to weigh the basket, but now you have this long boom, this long reach. So we need to look at longitudinal and side forces here. So there are a few main load sensing locations that are required to meet the safety regulations. Again, ANSI 892 is the US standard. We've described how the basket weight is monitored, but on the larger reach machines, the OEMs are not just concerned with basket weight, they're concerned with stability and extending their work envelope. The introduction here of a multi-axis load pin gives them real-time stability analysis on the machine. The load pin is typically mounted at the root of the main actuator, as you can see there, circled in green. This pin is the only thing that's holding the actuator in place, so it's receiving all of that force. Unlike the shear beam load cell, which is parallel to the mechanism that's holding the platform, the instrumented pin is dual axis and allows them to calculate the stability of the machine. Together, the 2 sensors outputs give them real-time envelope evaluation for the machine. At any given combination of elevation, extension, and weight, they know if the machine is stable or not. So again, these pins can be customized to meet existing applications, and so to make it plug and play. These all have CAN output, which seems to become the standard, but we offer other outputs as well. We have customized compensation capabilities, factory stored calibration, different types of connection methods, cable lengths, and again, coatings and so forth. So these devices are all highly customizable, and like we've been mentioning, we work pretty well with our OEM customers, so we can pretty much fit into any of their applications. All right, let's go to the next slide. All right, so now we're going to talk a little bit about customized force sensing, which is kind of started to allude to that. This is just an application where you've got a grater that has a ripper element on the back and a grater in the front. VPG is continually evolving the capabilities of the traditional load cell. And again, we're working with the customers to rethink how to monitor the forces within their machines. An example here is where a customer has an existing machine and they would like to optimize its performance by turning, let's say, an existing mechanical support or link into a sensor. VP engineering can analyze an existing structural component that might be capable of being machined and instrumented to provide a meaningful force data. This approach, by taking an existing component, this approach minimizes the structural design changes that might be required to mount, say, a traditional sensor. So now we're just plugging right into the existing thing. They don't have to change any of their structural components, and we're getting them meaningful data. In addition of our digital control circuit, it can provide for multiple measurement types, like we mentioned before, and afford potential cost savings by eliminating the need for multiple sensors. Another example, say if a customer wants to control the depth of the ripper that you see in the back here, on the back of the grater, we could instrument one or more of the plow bars, so they would sense the change in drag and help the operator to maintain an even or level grade. Similarly, we could instrument a support on the adjustable blade so the operator can monitor the force as well as the orientation of the blade surface. So, the capabilities that we have now with our digital circuits and our design efforts to fit into pretty much any mold really put us well above some of our competitors. Let's move on to the next slide.
Okay, thanks, Richard. So yeah, just you would have heard us mention EDOC in many of the applications that we've discussed before. Basically, this is a VPG solution to provide the ultimate in protection for the mechanical components within the load cell. Historically, many customers would have coated load cells to provide protection with either paint or epoxy, or in aluminium's case, some kind of anodizing procedure. But those solutions, they're not particularly long living. They can be easily removed or scratched. But now with this enhanced multi-layer protection, EDOC is the highest performance, most effective choice of protection of any load cell. As you can see from the slide here, EDOC on stainless steel offers better corrosion resistance than stainless steel alone. It's more cost effective than stainless steel on its own. And also we offer a proven 15-year guarantee of operation. It's already used in over 500,000 machines with top performance, with no corrosion after 1,000 hours of salt fog test. And it offers total peace of mind for the load cell. We do a lot of work on making sure the electronic components of the load cell are sealed. But if the metal work of the load cell is compromised, that will in turn compromise the electronics of the load cell. And currently, we're guaranteeing 15 years of zero defects of the actual metal work of the load cell with our own EDOC coating. And as you would have seen in many of the applications that we've presented, it's becoming a standard offering specifically to construction, but also across other markets. Food industry, for example, has the same challenges as the construction industry in terms of moisture and dirt. So yeah, it's an excellent solution to a long-standing problem in many industries.
Thanks, Darren. Isn't the English accent awesome? I just loved his pronunciation of aluminum.
Aluminium.
Yeah. All right, just before we get into the question and answers, I just want to say, there are any number of applications where VPG can provide an innovative, highly customized product that can be seamlessly integrated into your applications. So please contact VPG today and let's discuss the opportunities to improve your machine's safety and efficiency. All right, so let's take a look at some questions and see if we got some answers for them. Paul's been waiting patiently.
So what are the questions that we're looking at today?
All right, I guess I have to click a button here. Yes, that would help. All right, let's see here. First question, why would a load cell be better to measure force as compared to a pressure sensor?
Yeah, so many of the systems today, they rely on just measuring the pressure in the hydraulic system. But this is no longer accurate enough to meet the latest regulations. So the pressure is regardless of the accuracy of the pressure sensor, the pressure itself is not accurate. It's fluctuating. It's not repeatable. It's not linear. So this is one issue. The other issue is the new regulations require you to be able to weigh from the start. Whereas when you are using pressure, you must generate the pressure and start movement, and you cannot measure before you're at a certain level. Whereas with the weight, you get an instant reading immediately, sometimes even on the ground, depending on the structure of the machine. So this is another major advantage for the force. Indeed, it's in most cases, the pressure sensor will be a lower cost, but it's in many cases, it will no longer meet the regulation. Also, as we mentioned, we are adding more and more outputs to the electronics. So in addition to force, we offer also temperature measurement, we offer tilt and vibration. And our newest offering is we offer an inertial measurement unit built into the sensor. So basically, this is a small gyroscope that allows you to measure the movement of the platform, not just the vibration or the tilt. This can be used to calculate the trajectory of the arm if you desire. And all of these outputs are available in redundancy. You can either have one of each or two of each. And in the same sensor, everything is embedded. So this gives you a big advantage, and sometimes you can replace your standalone tilt sensor mounted elsewhere in the machine and use the integrated tilt sensor.
Paul, do you know, this is one of the other questions on there. Are there other protocols allowed on the same sensor? Can you do multiple, like say CAN bus and RS-45, or do we typically stick with just one or the other?
We're not doing it at the moment. This is mostly relating to the machine. Each vehicle will have a bus of communicating with a certain protocol. So we have to match that. We can definitely address this issue if it comes up. We did not run into it yet, but we can address it either by adding connectivity to the existing board or using two separate boards. So you get redundancy. One channel is in CAN, one is in a different signal.
Thank you. Let's see what else we have here. Here's one. It says, generally speaking, how many strain gauges are used per load cell, or does it just depend on the size of the load cell? And then they add, additionally, do more strain gauges make for a more accurate reading?
So if you have typically, if you have a single output, it will have a full Wheatstone bridge, meaning it will have 4 strain gauge grids. If you have a dual output, you'll have 2 separate Wheatstone bridges. Each bridge will have its 4 grids. And yes, in general, as you add strain measuring elements and distribute them across the pin or diaphragm, depending on the design of the sensor, you will increase the accuracy. But then there are also issues of limitations of space. So it's up to the design if it's a shear beam, if it's a pin, if it's a dual-ended beam, if it's a single-ended beam. There are many considerations, but typically you will have a full bridge with 4 strain gauges. And typically, if you increase the number of strain gauges, you will increase the accuracy.
All right, here's one related to the last topic that Darren spoke on is can EDOC be applied to any sensor? And if it's applied to a load pin, will it show signs of wear?
Okay, so the EDOC can be applied to any metal body and maybe even non-metallic, but we didn't experiment with that for now. So we do it regularly on aluminum and on alloy steel. It can also be applied to stainless steel, but the issue with pins is not the wear, is the tolerance. The EDOC will not allow you to maintain a tight fit tolerance. So if you have a bearing fit, the EDOC is not a good choice. Or you can have a selective coating, meaning that the areas with the bearing will have a different type of coating. And so that will fit into the bearing. It's not the wear issue, it's the fit issue.
Perfect, that makes a lot of sense. Thank you. All right, here's one more here. It says on the telehandler application, is an extensometer actually measuring the load?
No, it's not measuring the load. The extensometer is mounted on the axle, and it's measuring the deformation of the axle under load. Remotely, you can connect, but it's very, very crude, maybe 5 to 10% accuracy if you want to use it for weight measurement. The mounting of the extensometer on the axle is to detect when load is lifted or nearly lifted from the axle. So it's not used for load measurement or weight measurement. It's used more as an on-off switch. Load, no load, or close to no load. And this is greatly demonstrated by the 7-segment display. This is roughly the accuracy you can expect if you want to do weight measurement. So it gives you a very rough indication. You have lightweight, medium weight, full weight, no weight.
Thank you for that. Looks like we have one more question from these anonymous attendees. It says, is it possible to add Bluetooth to the load cells force sensors to enable wireless connection or diagnostics?
Yes, it is. But the question is for what reason? We have tested various wireless communications, both for wireless sensors and for other applications. So yes, it's possible to add, but sometimes you may have an issue with the power source. If you're already running cables to the sensor, then you can run the signal out. So we may be seeing it coming out in the future based on demand. But at the moment, we're not including it in our transmitters. If it's under review, and we will add it as required. But currently on our CAN transmitters, we don't have it.
Excellent. All right, that was all the questions that were posed. I'll hand this over. Thank you very much, for myself, for the US group. Thank you very much for attending. We look forward to some follow-up questions and your responses to the survey. Darren?
Yeah, and likewise from my side, from the European team, thanks everyone for attending, and hope you found it useful and informative. As you can see, we truly are an expert in the force sensing load cell industry within the construction market, and we look forward to hearing from all of you and all of our customers, and presenting your challenges moving forward. So in terms of contacting us, obviously you can see here Richard in the US, email, and obviously on LinkedIn, and similar to myself, but also for anyone that's from the Asia Pacific region, Sakti Kumar is our equivalent in that region, and you can see his details there. So we do operate regionally, but we all work as one team. So please feel free to reach out to any of us with any of your design challenges and new projects, and yeah, we look forward to working with you all in the future.
All right. Thank you, everyone. Appreciate it.
Thank you, Richard. Thank you, Darren.
Thanks everyone.
Bye.
Are we done? Darren, that was awesome. Thank you. Appreciate it.
No problem.